All right, number 11 is another solve. And so we want to get rid of those fractions. I'm going to factor this guy's denominator. So that would be x minus 5, x minus 2. So now I'm going to multiply both sides by whatever the denominator is. So x minus 5, x minus 2. And so when I multiply the left side by it, I have to distribute it. So x minus 5, x minus 2, x minus 5, x minus 2. I'm just writing them on top of each other like that because there's not a lot of room. And so what this does is cancels fractions. X minus 5's cancel. Everything canceled over there. So we have 3x times x minus 5 plus 2x times x minus 2 equals 5x squared minus 16x plus 21. All right, I'm going to distribute 3x squared minus 15x plus 2x squared minus 4x equals 5x squared minus 16x plus 21. And now we're going to combine like terms that are on the left hand side. 5x squared, 15 minus 4, that's negative 19x equals 5x squared minus 16x plus 21. And minus 5x squared both sides. And now I'm going to add 16x to both sides. That's a negative 3x equals 21. So x is negative 7. And that is not one of our restricted values, so we're good because x, remember there can't be a 0 on the bottom of a fraction. So x can't equal 2, that gives you a 0. And x can't equal 5. But we didn't get 2 or 5, so we are good. All right, the square roots. So the square root function, the parent looks like that. Over 1, up 1. Over 4, up 2. 1, 2, 3, 4. 1, 2. Because the square root of 1 is 1, the square root of 4 is 2. And this one is going to the left 2 and down 3. So that starting point is left 2 and down 1, 2, 3. And then over 1, up 1, over 4, up 2. And then my next square root is 9. So over 2, 4, 6, 8, 9, up 3. So I can remember that because it's just square roots. Over 1, up 1, over 4, up 2, over 9, up 3. So this is x, this is the square root of x. Or you can look at your equation and plug in x values based off of where your starting point is. So if my starting point was x value negative 2, so I would plug in to the right of that. Plug in negative 1, 0, 1, 2, 3, maybe skip a few and do more. And then you plug it into the equation to get your actual values that you plot from 0, 0. These are actual points that you graph starting from the origin. Whereas this is the little tricky thing that you're not starting from the origin, you're starting from the starting point. Over 1, up 1, over 4 up 2 over 9 up 3. So if I plugged in -1, -1 plus 2 is 1. The square root of 1 is 1. 1 minus 3 is -2. Erase that. Plug in a 0. The square root of 2 is about 1.4. And then we're minusing 3. That gives me -1.6. Plug in a 1. The square root of 3. I just need my calculator to just clear out. And it won't cooperate. What am I doing? 1 plus 2 is 3. So we have the square root of 3 equals, and then minus 3 equals -1.3. Plugging in a 2. 2 plus 2 is 4. The square root of 4 is 2. 2 minus 3 is -1. So you'd start graphing those. -1, -2, 0, 1 point, down 1.6, over 1, down 1.3, over 2, down 1, and you would keep going until you had a nice good curve. State the domain and the range using set builder notation. All right, our domain x such that, so domain is left to right. So starting on the left, the graph does not exist. Boom, it starts right here at -2 and goes forever to the right. So x is greater than or equal to -2. And the range is the y values, y such that, and so it's down here at -3 is where it starts and then goes up forever. Y is greater than or equal to, what was it? -3. And that's our domain and our range. Write the end behavior of these functions. All right. So I'm going to just make a little sketch so I can look at the graph. This negative in front, that means it's reflected across the x-axis, so up and down. And it is also to the right 2 units. So we're starting there, and instead of going up, it's going down. And so what am I saying? End behavior. So as x approaches positive infinity, and then the second part, as x approaches -infinity, you want to say what the graph is doing. So as we go to the right, the graph is very slowly, but it's going down, 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 -infinity. And then as we go to the left, it stops there at 2, and it doesn't go past that. And we've got another one. So this one is moving to the left 1 and down 1, 2, 3, 4, 5. And it's got the normal curve. So as x approaches positive infinity, f of x approaches, as you go to the right, it keeps going up, 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 up. Positive infinity. As x approaches -infinity, f of x approaches, as you go to the left, it stops right there at 0. Alright, if this function were translated left 7 and down 8, what would the resulting function be? So you might be able to just look at this and then think about it and figure it out, but I always have to draw the sketch because my brain, that's how my brain works. So we're going 1, 2, 3 to the right, 1, 2, 3, 4, 5. So our starting point's right there. This is the shape is a little affected by 1/2, but that's not affecting the starting point. The starting point is still to the right 3, up 5, and it's also going in the negative, reflected, but that doesn't affect the starting point. All I really care about is this starting point. So if I translate it to the left 7, so that'd be 1, 2, 3, 4, 5, 6, 7. So that would be 1, 2, 3, -4 for my new starting point. But now we got to go, what do we got to go? Down 8. So we're up at 5, and then if I go down 3 more, that would put me at a total 8 down. So this point here is to the left 4 and down 3. Let me just check my work on here. Man, I just was getting all kinds of, I think I messed up, you guys. Yeah. This one, back to this guy. So it was to the left 1. I accidentally put it on the axis there. So we're 1, 2, 3, 4, 5. And to the left 1, so it would have been here, which means that should have been, as f of x approaches, -1. All right, back over here, our new starting point. If this function were translated, what would the resulting function be? So we got to say its new equation. So it would still say -1/2 times, and now, so our new x value is -4, so that'd be x plus 4, and our new y value would be a -3. And that is what I got on when I did work these out already, so we're good. Number 15, translate this graph 4 units down and 6 units right. What does the graph look like after the translation? So the parent function, the cube root of x. I'll do the parent function here. So I'm just thinking about plugging in x's. The cube root of 0 is 0, so 0, 0 is our inflection point. If I plug in a 1, the cube root of 1 is 1. If I plug in a 2, the cube root of 2 is, I don't know, some decimal. Plug in 3, cube root of 3, cube root of 4, cube root of 5. It's not until I get to 8 that I come out with an even number, or not an even, but a whole number, a non-decimal. The cube root of 8 is 2. So over 1, up 1, over 8, up 2. And then the other side does the same thing, but negative. -1, -1, -8, -2. Left 1, down 1, left 8, down 2. So now we're going to move this 4 units down and 6 units right. 1, 2, 3, 4 units down, 1, 2, 3, 4, 5, 6 units to the right. And it would have the same proportions. Over 1, up 1. Over 2, 4, 6, 8, up 2. And left 1, down 1. And left 2, 4, 6, 8, down 2. There we go. Is that all what does the graph look like? There it is. So this one is the parent. and this one is the new one. So let's write its equation. So we went 6 units to the right, so x minus 6, and then we went down 4, so a minus 4. All right, now our exponentials. I'm going to check the time really quick. 15 minutes. Well, the other one was like 24 minutes, so we can do a couple more. We'll do this number 16. Graph the functions and describe the domain and the range. Ugh. Okay, so the base is above 1, so this is exponential growth. And it is going to the right 4 and down 5. So the down 5, that's the important part. Exponentials have horizontal asymptotes. So its asymptote is down here at -5. So normally, if this didn't have this 3 and it didn't have that x minus 4, we would just go 1 unit above at the origin, and then we could plot a couple points that way, and we wouldn't have any plot any going this way. But we're going, what were we going? To the right 4. So 1, 2, 3, 4. And then we're not going to be 1 above because of that multiplier by 3. And so it's best to just plug numbers. So I know I'm going to start with the x value of 4 because I know we're going to the right 4. 4 minus 4 is 0. 2 to the 0 is 1. 1 times 3 is 3. 3 minus 5 is -2. So over 4 down 2. And that makes sense because that multiplier in front is a 3. So instead of being 1 unit above, it's 3 units above. So now I'm going to go to the left, and I'm not going to plug in 3. I'm going to skip and do 2. 2 minus 4, so I'm going to use my calculator and do this as I work. So 2 minus 4 is -2. So 2 to the power of -2 equals times 3 equals, and then minus 5 equals -4.3. Over 2 down 4.3. So that got us within 1 unit of the asymptote. So I can just go like that. And now I'm going to go to the right. So 1 unit to the right of 4 is 5. 5 minus 4 is 1. 2 to the 1 is 2. 2 times 3 is 6. 6 minus 5 is 1. Over 5 up 1. And we could probably plug in one more. Let's plug in 6. So 6 minus 4 is 2. 2 squared is 4. 4 times 3 is 12. 12 minus 5 is 7. So to the right 6 and up 7. And that looks pretty good. Graph the functions and say the domain and the range. So our domain is left to right. It's going forever left, forever right. Or you could do all real numbers in Set Builder. Range is bottom to top. So this graph is stays above -5, not including it. So I do parentheses, not a bracket, -5 to infinity. Or y such that y is greater than -5 if I do the set builder. And I guess I should have written this properly. There we go. And now this guy. The base is a fraction, less than 1, so it's going to be decay. And we're going to the left 2 and up 1. So up 1, that's our horizontal asymptote. And so normally we would be right there. Oops, on the, come on guys. I don't want to add, oh, my screen froze a little bit. Whoa. I don't even know what happened. So normally we would be 1 unit on the axis above the asymptote, and it's decreasing, so I plug in a couple points over here to get the curve, and this one just goes towards the asymptote. But we're left 2. So that point there moves right there. Boom. So the right is going like that. There's no multiplier in front here. It didn't have some number sitting in front. So yeah, that's that. So let's see where it goes. So to the left of -2 is -3. Let's plug that in. -3 plus 2 is -1. 1/2 to the -1 is 2 over 1 to the +1. So that's 2. And then plus 1 gives us 3. -3, +3. And now I'm going to plug in, should I skip -4 and go to -5? So -5 plus 2 is -3. 1/2 to the -3 is 2 to the +3. So that's 8. 8 plus 1 is 9. So to the left 5 and up at 9. And that fills up our grid pretty well. All right. And the domain, -infinity to +infinity, and our range is 1 to +infinity. There we go. So I'm going to stop right there if I can, and stop.